Example of a root function. F of x is equal to the square root of negative 2x plus 3 minus 7. And as you can see, we have to first factor it into f of x is equal to negative 2 bracket x minus 15 minus 7. So now we have to list all the transformations that take place in this function. As you can see, we have a negative, so that means there's a reflection on the y-axis, right? And then you can see the 2 is telling you that there is a horizontal compression, because you have to remember, once you take it out of the root function, it is the opposite, and you have to switch it because it's the reciprocal. So a horizontal compression by a factor of 1/2. You also have a horizontal shift of 1.5 units down. So 1.5 units down. Because remember, when you factored this out, you have to factor out a negative 2 from the 3, so you're left with a negative 1.5. And you're also going to have a vertical shift of 7 units down, because you have a negative in front of your 7 here, and that indicates that it's actually going down. This is an example of what you would have for a root function in listing its transformations. You're going to have to write it in mapping notation, and for that, as you see, you have to factor out the negative 3 from the negative 6 in order to make sure that your equation is correct. So you're going to have f of x is equal to the square root of negative 3 x plus 2 bracket plus 2. And now you have to apply this to your x and y values. Your x and y values. So you're going to have to multiply your x values by negative 1 over 3, because remember, you take out the negative 3 and it becomes a compression, x minus 2, because the plus 2 it's opposite. And then your y values are y plus 2, and that's from that number. So now you're going to have negative 2, 2, negative 2.333, negative 3.33, and 4. And to graph this equation, it will look something like this. And you can see that it starts here, and it works its way this way, and it's forever moving in that direction. And it tells you that the domain and range, so the domain is x, such that x is an element of all real numbers, such that when x is less than negative 1.5, and your range for this is y, such that y is an element of all real numbers. Because in your graph, y will forever, there will be infinite possibilities of the